All right, welcome to the Explainer. Today we're heading straight to the whiteboard for a deep dive into a really brilliant new paper called Beyond Fixed Representations. And we're going to map out exactly what is fundamentally holding artificial general intelligence, AGI, back right now. I mean, if you've been watching the incredible headlines lately about AI coding, reasoning, discovering new proteins, you might think true AGI is literally right around the corner, right? But today we're going to draw out the hidden, structural walls these models are hitting. And more importantly, we'll look at how researchers propose we actually break through them.
So I want to hook you immediately with this paradox we see in the real world. Just think about it for a second. Why is it that a modern AI can synthesize thousands of lines of complex Python code, or absolutely ace an advanced math competition, but it cannot autonomously invent a completely new foundational concept? Well, as we're going to see, current AI progress has a bit of an illusion to it. It's incredibly powerful, no doubt about it, but its intelligence operates under a very specific set of constraints. Let's take a look at what those constraints actually are.
Section 1. The limits of current AI. Okay, let's dive into this. To understand how to build truly open-ended intelligence, we first have to understand the invisible box that current systems are trapped inside. You see, intelligent activities generally fall into two completely different buckets. On the left, we have type 1 problems. This is basically searching within a fixed box. You've got a goal, a defined set of rules, a fixed vocabulary, and an evaluator. Things like chess, coding, theorem proving, these are all type 1. The AI is really just searching for the best combination of existing pieces. But over on the right, we have type 2 problems. This is open-ended innovation, where you actually have to change the box itself. You have to invent new concepts, new measurements, or new evaluators to solve problems that were previously impossible to even describe. And the catch? Current AI absolutely dominates type 1, but is fundamentally stuck when it comes to type 2.
Section 2. The two innovation gaps.
So to move from that type 1 problem solving to type 2 open-ended innovation, the researchers identified two massive bottlenecks that are just holding the whole AI industry back right now. The first one is what they call the vocabulary gap. Now, actually scratch that. It's not about the AI needing to learn more English words. It's about the sheer difficulty of inventing entirely new representational primitives. Let me give you a quick analogy here. Imagine human history before the invention of negative numbers. You literally couldn't solve certain algebraic equations because the concept itself, the primitive, just didn't exist yet. Or think of the concept of entropy in physics. Somebody had to invent that concept to make invisible patterns measurable. Current AI, it just recombines primitives we've already handed to it in its training data. It doesn't look at a totally foreign problem and invent its own negative numbers to solve it.
Which brings us to the second bottleneck, the verifier gap. And this brilliantly illustrates why open-ended discovery is so incredibly hard. When an AI writes code today, it relies on cheap, super-fast verification, like running a unit test. It writes the code, runs the test, passes or fails, easy. But true scientific discovery doesn't work like that at all. If an AI invents a completely new concept, how in the world does it test it? The future tasks that make this concept valuable might not even exist yet. The paper calls this the uselessness of the useless. A new primitive might seem totally useless today, but completely revolutionize a field tomorrow. And right now, current AI has absolutely no mechanism to value and hold on to a concept if its payoff is delayed and unmeasurable by today's metrics.
Section 3. Cognitive discrepancy reduction.
So let's break down the underlying theory. Intelligence, at its absolute core, is really just about closing the gap, or the discrepancy, between where you are and where you want to be. Step 1 is the input, which is your current representational state. Step 2 is the process, meaning a cognitive transformation. This could be making an analogy, compressing data, or, crucially, inventing a new concept. And then step 3 is the output, achieving your target condition. Basically, whenever an intelligent system hits a problem it can't solve, it applies a transformation to reduce that discrepancy.
But here's the catch. When we translate the underlying math of modern AI into plain English, a massive blind spot emerges. Consider the major frameworks driving AI today. Minimum description length is all about compressing data. Structure mapping is about finding analogies. Free energy is about reducing prediction errors, which is exactly what next token prediction does in large language models. And look, they're all beautifully execute step 2, the process of transforming data, but they only search within fixed representations. If a problem requires completely changing the frame, like inventing a whole new language to describe the problem, none of these frameworks are mathematically equipped to do it.
Section 4. the ladder of autonomy.
Okay, let's shift gears and look at the real-world landscape of AI right now. We can basically grade this into 4 levels of autonomy. Down at level 0 is direct search. Think standard LLMs or basic RAG systems. You ask a question, it searches its fixed knowledge, and gives you an answer. Level 1 introduces a basic improvement loop. The AI generates something, gets feedback from a fixed verifier, and tries again. Then we step up to level 2, scaffolded representation. This is where an AI might search through different hypotheses or code libraries, but, and this is a big but, a human is still providing the tools and the ultimate definition of success. Finally, right at the top is level 3, open-ended innovation. This is the holy grail, an AI that autonomously detects gaps, invents its own vocabulary, stores it, and revises its own grading criteria.
Now, what's really interesting is when we plot today's most advanced AI systems on this ladder. Notice the heavy clustering? AlphaFold, AlphaZero, FunSearch. They are all sitting right down there at level 0 and level 1. Even the highly publicized AI co-scientists and automated lab agents, which are doing absolutely incredible things, max out at level 2. They're all operating inside heavily scaffolded, human-guided loops. They are brilliant at searching, for sure, but they aren't inventing the fundamental building blocks of their search space.
And here is the stark visual reality. Level 3 is completely, utterly empty. True, autonomous, open-ended invention, the ability to generatively change the frame, invent new concepts, and evolve evaluators is fundamentally missing from today's tech. And you know what? Just scaling up compute or throwing more and more data at next token prediction isn't going to magically populate this top tier. We literally need a new blueprint.
Section 5. Building open-ended intelligence.
So how do we actually fix this? To build open-ended intelligence, we have to rewire the underlying architecture through 4 major shifts. First, we need completely new training objectives. We've got to stop just rewarding AI for predicting the right answer and start rewarding it for useful representational change, for taking messy data and creating a clean, reusable abstraction. Second, we need trajectory data. Instead of just feeding an AI the final, polished textbook answer, we have to show it the messy before and after of how a concept was historically invented. Third, we need persistent memory stores. When an AI invents a good primitive, it needs to save it, test it across different domains, and actually consolidate it into a core knowledge base. And fourth, surrogate verifiers. Since long-term scientific value is hard to test immediately, the AI needs internal heuristic signals, like measuring if a new concept makes data dramatically easier to compress, to basically guess if an idea is worth keeping.
I love how the researchers sum this whole thing up. They say the deepest advances are often not new answers, but new primitives, a variable that did not previously exist. And that right there is the ultimate takeaway. Intelligence isn't just about perfectly navigating the maze someone else built for you. True artificial general intelligence is going to require the ability to look at the maze, realize it's the wrong shape entirely, and autonomously invent a completely new dimension to step right out of it.
So I'll leave you with this thought. As billions of dollars pour into training massive models to perfectly solve today's benchmarks, are we just building the ultimate test takers? Or will the next generation of AI actually be able to invent the concepts required to understand problems we don't even know we have yet? Thank you so much for joining me on The Explainer today. Keep learning, keep questioning, and I'll see you next time.